Okay, so now that we understand how to source from a sub-object, let's take a quick look at the most important attributes that you will be using, at least the ones that you will be using most of the time. So as I've mentioned before, the flip solver has a huge amount of attributes and properties, and some of them, to be honest, you won't be using all of the time, or it will really depend on the type of simulation you're creating. For example, some properties are very useful for large-scale simulations. Other you will use for small-scale simulations or very specific type of fluid. For example, viscous fluid or even more abstract stuff. So I will select the flip solver. And one of the first things I want to bring your attention to is we have two important tabs, particle motion and volume motion. And if you remember in the first chapter, we talked about that you will usually input particles and a surface volume, and then the flip solver will create an additional volume, or actually several different volumes. One of the most important being the velocity volume that will advect the particles during the simulation. So this tab will help you change most of the attributes and parameters for those volumes that are being created and are driving the simulation. And the particles motion on the points, particles, and attributes. So let's start with this tab, particle motion. First of all, one of the things that I do every single time I create a flip simulation is turn on H particles and add ID attributes. Now, the only drawback to adding these attributes is that you'll end up with more information when you cache your simulations, but remember that at any time you can delete whatever information you're not using, and you never know when you're going to need specific attributes. But let me explain. The ID attribute gives you an integer value for every single particle, and that value won't ever be the same again, and it won't be repeated. That's very useful, for example, if you want to do specific selection of particles, or probably you want to run a vex code that it's not dependent on the particle number. Most of the times when you're creating flip simulations, the particle count will be changing by frame, and the ID attribute will give you the means of controlling the particles without necessarily depending on their point number. So again, this is something that you may use in very specific cases, but I just like to have that attribute around just in case. Now, the H particles, I think it's even more important because this will make the particles aware of how much frames have they lived. And this is important in some cases if you want to do post-processing, for example, change the color of the particles by time, or probably make the p-scale change depending on how much time they have been alive. Perhaps if you're doing some abstract or magical effect, you will want to change its color or stuff like that. Aside from the ID and age attributes, there's a few important parameters here that I usually try to check before simulating. And first of all, there's reseeding. What this group of parameters tries to ensure is that we usually have the same volume of particles. So if at some point we start losing particles, probably they're being deleted or they start to spread too thin, the solver will add particles to try to close gaps and to try to maintain the appearance of volume on the fluid. This parameter by default will be on, and most of the cases you will want to leave it on. There might be situations where you don't want the particle count to change, and in that case it would be very important to turn reseeding off. But again, most of the time I'll just leave it on. Another very important group of particles is under droplets. Now, usually droplets are off, but most of the time I like to turn this parameter on. So when this option is on, the solver will try to detect when particles are being isolated from the group, and it will either try to bring them back to the rest of the particles to join them back or simply remove them. and you can have certain control of what's happening with the behavior. So blend with fluid will try to bring the particles back to the group, as I mentioned. You can also change this option to kill on detection if you don't want to see these droplets. What I usually like to do is just leave this in blend with fluid. In any case, whenever you turn this option on, there will be a droplet attribute created that will let you delete these droplets afterwards, which I prefer. Or you can do stuff like change their colors, increase their particle size. In the end, you will have a little bit more control if you turn this option on. And finally, the vorticity. This option is extremely important, especially if you want to create white water after the flip simulation, which you will want to do in most of the cases. So this is one more property that I usually make sure that is on before I start simulating. If for some reason you forget to turn this option on, simulate and then find out that you want to create your white water, most of the time you will need to resim because you will be lacking the vorticity attribute. So make sure not to forget to turn this on. Here under the rest tab, you can create a rest attribute if you need the coordinates of where the particles are being born. And this can be useful, for example, if you want to add color to the particles or try to simulate UVs, but I won't dive into this specifically in this course. We also have the separation tab that will try to maintain particles separated, and this can be useful especially in small scale simulations. Again, this is something that I won't touch on this particular course, but of course you can also come in here and experiment on your site.